All right, so these are some more examples of area between two curves. So maybe we always start by drawing that little rectangle so that we can figure out who is the top and who is the bottom. So if you look here, our top is the y equals 2x plus 1, and our bottom is the curve 2x cubed plus 1. And you can look at this by our graphing that we've done before with our parent functions, or just by plugging it in your calculator. And with our rectangle, we know the height is y equals, and that's where I'm getting these. It's y equals 2x plus 1 for the top, and 2x cubed plus 1 for the bottom. And they have a width of dx. So we would know that the integral here is our top. Take away our bottom, make sure we put that in a parenthesis, and then with a width of dx. Now we just need to start to finish. And the first thought would be to go from -1 to 1. And where am I getting that? Well, we just set them equal and solve. So we go 2x cubed plus 1 equals 2x plus 1. And then we subtract everything over. And those cancel. And so we get 2x cubed minus 2x equals 0. Factor out the 2x. And x squared minus 1 equals 0. So 2x, x minus 1, x plus 1 equals 0. So x equals 0, x equals 1, and x equals -1. So we actually have 3 points of intersection. It's a good thing to notice that, because if you just say, oh, it's going from -1 to 1, it would come out to be incorrect. In fact, let's see what it would come out to be. It would come out to be 0. I wonder why. Well, if you notice here, the top function is changing. So as we drive this rectangle through our function, so we're starting at -1 and we're going to go all the way to 1. But if we start at -1, you can notice that our top function is the cube and our bottom function is the line. And then as we transfer over that 0, now they've switched. So the top function is the line and the bottom function is the cube. So what that means is we have to do the integral twice. One from -1 to 0, that would be the top function of 2x cubed plus 1 over 2x minus 1. And then as we move to the next side, now they've switched and we do 2x plus 1 here and 2x cubed minus 1 plus 1 there. So noticing those points of intersection can tell you when things cross over like that. And so what we have to do now is, well, we need to draw another rectangle right here. And so this would be the same thing, dx, y equals, but now our top is 2x cubed plus 1 and 2x plus 1. So we're going to end up getting two integrals. So for the one that we did here, I'm going to move it over so that we can go from left to right. So this one goes from 0 to 1. Starts here, ends here. The other one goes from -1 to 0. So our x value is -1 to 0. And now our top function is 2x cubed plus 1 minus 2x plus 1 dx. And then we just add them together. And remember, always make sure that everything here is x's. By solving for y, all our functions are going to be in terms of x. So we're going to be plugging in x's. We're also moving across the x-axis with these rectangles. So if you follow the rectangle, what we are actually doing is moving through the x values as we move from left to right. So it's our dx that we're focusing on when we write these. Now we just have to plug these in the calculator and see what they are. And so we get 0.5 for each of them for a total area of 1. So if you see the top becomes the bottom, then wherever they split, you got to make sure that you change the integral into two integrals. You can also look for symmetry and then just double it. That is another option. But we can't do one integral from -1 to 1. You're not going to get an area of 0 between two curves unless they're exactly the same curve. All right. The other type that's going to happen is there won't be a point of intersection. So what they will do is give you the actual starting and finishing values. So you can see we're going from -1 to 2. So if you already know it starts at -1, ends at 2, these two are done. We've used them. Now we can focus on our function. Same thing you want to do, draw that little rectangle. And so our top function here is x squared plus 1. Our bottom function is x. It's y equals, so everything's perfect. And then dx. So this one says y equals, this one says y equals. There we go. Putting in the top, x squared plus 1 minus our bottom, which is x. And I'm getting these because I know that's a parabola and that's a line. Already graphed them. Dx, and now we can just plug it in the calculator and get the area. And so that gives us 4.5. So there's our area. So by drawing that little rectangle, you just have to make sure the rectangle does flow through the entire problem. So if I were to draw the rectangle here, it would still be the exact same top and the exact same bottom, and we know we're good. So just like up there, it didn't. We had to split it. So let's try one more with some trig functions here. So what we have is sine x and cosine x. And so these pictures are done in Desmos, which is a nice thing to start. But if you don't have a picture, then you're going to take your calculator and you're going to graph it. So you'll plug your two functions in here. I'm not plugging these in because they're my x values. So I already know that by drawing that rectangle, they're already at y equals. But if they're not, I can go back and change them. And then I've plugged in 0 and pi over 2 here. And then I hit zoom and fit. And then it gives me this nice picture. And if I hit trace, I know which function is which, because it tells me with the color. We also know how the sine function looks. It's going to come from 0 and go up, and cosine comes down from 1. But you can even look that way as well. So the blue is sine, the red is cosine. And so you get that nice little picture, and you can figure out what everything is. And so if we take sine x and set it equal to cosine x, a quick little trick is to just divide it like that, and that will give us tangent x equals 1. And so we know that that would be at pi over 4, right in the middle, pi over 4. So why do we need this? Well, looking at that picture, either one, you can see that red is the top function and then blue. So it's cosine minus sine, and then it's sine minus cosine. So if we draw our first rectangle, our top function would be cosine x, again making sure that it says y equals, which it does, and it's dx. And then our bottom function would be the sine x. And then on the next one, green doesn't really work, let's do blue. We would know that it is the sine function on top, and then the cosine on the bottom. So we'll do the red first. From 0 to pi over 4, this would be cosine x minus sine x dx. Plus, and then now the blue, from pi over 4 to pi over 2, those are the two intervals, so we are going from 0 to pi over 2, but there's a split. Now it's sine x minus cosine x dx, and now we can plug each of these in our calculator and get our answer. So 0.414 and 0.414. So adding those together, you get 0.828. Now, if it asks for the exact values, then you can either use a little bit of thinking, which this is the square root of 2 minus 1 and the square root of 2 minus 1, and you can double them. Or you have to go back and actually do it by hand. So you end up with 2 rad 2 minus 2. So depending on what they want, whether it's an approximate or exact answer, with trig functions, you do have to actually go back and find them by hand. So there you have it.